Hi everyone, Miss Lorette here. I'm going to be reviewing sections 2.3 and 2.4 with you today. This covers how to solve multi-step equations. In particular, I'm going to be focusing on equations that deal with integers and also fractions. So you'll need something to write with, something to write on, and let's get to it. So before we actually dive into solving some equations, I want to take a moment to review some general steps and also types of solutions that we could be potentially getting. I generally break down the steps for solving any multi-step equation into 4 easy steps. The first thing that you want to look for is, do we have any parentheses? And if we do, we want to distribute first. Okay, you might not need to distribute, but if you do see parentheses, you must take care of that step first. The next thing that you'll want to check for after distributing, do you have any terms that can be combined? So combine like terms on each side of your equation, okay? So first distribute, then if you've got any terms to combine, do that. And then the third step will only happen if you have variables on both sides, so you might not need to do this step. The third step is to get all your variables on one side by adding or subtracting the variable term. So I'm going to say move variable to one side by adding or subtracting. And then the very last step, if you've gone through all of these steps and taken care of everything, you should have a 1 or 2 step equation at that point. So you would just solve that, okay? Now, a few notes that we should write on types of solutions. So now that we're dealing with more complicated equations, we're going to be potentially getting one of 3 types of answers. So one type of answer that you could get is something that looks like this. You just get the variable equals a number. When this happens, we say that this is just one solution. Okay, we have one solution, the variable equals that number, that is the answer. So up to this point, when we've been solving equations, these are the types of equations we've been solving. It's just a one solution equation. Now that we're solving more complicated equations, you could get something that looks like this. You could get something that looks like 2 equals 0, let's say. So when this happens, as you're solving the equation, as you're combining your like terms, trying to get all the variables to one side by adding or subtracting, what ends up happening is that the variable ends up canceling out completely, and you get a false statement. You get something that's not true. 2 does not equal 0, okay? When this happens, we write as our final answer, no solution. Okay, and it's important to note that when you solve an equation and you get an answer that looks like this, that would be your final answer, right? The variable equals the number would be your final answer. If you solve an equation and you get something like this, the phrase no solution would have to be written as your final answer. Okay, and then the third type of answer that we could potentially get is something that looks like this. So instead of a false statement, you get a true statement after all the variable terms cancel out. When this happens, we can write one of 3 things. Some textbooks will say infinitely many solutions. That's one way that you could say your answer for something like this. Some textbooks might refer to this as an identity because they look identical on both sides. And some textbooks might actually say all real numbers, okay? So long as you're writing one of these things when you get something like this, one of these things would be an acceptable way to write your answer. But the key thing is, if you're getting a no solution, the phrase no solution has to be your final answer. If you don't write that, you're not completely done. If you get something like this and you get a number equals itself, one of these phrases has to be your final answer. If you don't write one of those phrases, you're not completely done. Okay, so let's do a little bit of review with solving some, or not solving equations yet, but rather reviewing how to do operations with fractions, because as I mentioned, some of the equations that we're going to be solving deals with fractions. So we've got all sorts of operations here. Take a moment to copy these examples in your notebook, and I will guide you through. Okay, so for the first one, right off the bat, I'm noticing some double negatives. Hopefully you know that when you've got double negatives, that's the same thing as a positive. The next thing that I'm going to do is anytime I see a mixed number, I convert it to an improper, just because visually that's easier for me. You might be fine working with mixed numbers, and if that's the case for you, then I say go for it. But I'm going to multiply my denominator with my integer. That's going to give me 18, plus the 1 in the numerator, that gives me 19, and I'm going to convert that mix to an improper because that's what's easier for me. Now, before I can add or subtract these fractions, I need their denominators to be the same. That's the case every time when you add or subtract fractions. So I need to find their least common denominator. So I'm looking at 2 and 6 and asking myself, what's the smallest number they can both create through multiplication? Well, the smallest number they can both create is 6. I don't have to change this second fraction because it already has a 6, but I do need to change this first one by multiplying by whatever would give me a 6 in the denominator. So to go from 2 to 6, I would multiply by 3. What I do to the bottom, I must do to the top, and I'm going to rewrite these fractions as equivalent fractions. If I multiply here, I get 9 over 6, and then I'm just going to bring down my plus 19 over 6. Now that my denominators are the same, I can add these two fractions together. My numerators, when I add, gives me, nope, not 25. That's going to give me 28. And my denominator stays the same. Now, in the world of mathematics, when you're dealing with fractions and you get a fraction as an answer, you're not done if it can reduce, and you don't reduce it. So you have to reduce when it's possible. When I look at both of these numbers, I notice that they're both even. All even numbers are divisible by 2. So let's do that first to see what we get. 28 divided by 2 would give me 14. 6 divided by 2 gives me 3. And 14 thirds definitely does not reduce any further, so I would be done here. This is my final answer. Okay, so let's take a look at the second problem. Again, I see a mixed number, so I'm going to actually convert that. And I also see an integer. Now, when we're adding and subtracting with fractions, and you are dealing with an integer, I highly recommend putting that over 1, so that way you can see the denominator clearly. So I'm going to rewrite this as 2 over 1 minus, I multiply, then add, that's going to give me 6/5. And I'm going to basically repeat what I did here for the first one. I'm going to find their LCD. So when I look at 1 and 5, I'm asking myself, what's the smallest number they can both make? That would be 5. Again, I don't have to change the second one. I got lucky here, but I do have to change this first one. And to go from 1 to 5, I simply multiply by 5. This first fraction is going to turn into 10 divided by 5. Second fraction stays the same. And now I can subtract my numerators. 10 minus 6 will give me 4. Denominator stays the same. 4/5 doesn't reduce. Here's my final answer. Okay, so let's do a little review with multiplying. Now, the nice thing about multiplying fractions, you don't need the denominators to be the same. You just multiply across the tops and you multiply across the bottoms, making sure that you reduce your final answer if possible. Now, what I like to do is rather than reducing at the end when the numbers have gotten bigger through multiplication, I like to reduce first. That's known as cross-canceling or cross-reducing. You're looking at the tops and bottoms and seeing if any number can divide evenly into both. So I'm looking at 55 and asking myself, can I reduce that with 7 or 4? And the answer is no. So I can't cross-reduce anything with 55. Then I'm looking at the 3 and asking myself, can that reduce with 7 or with 4? And the answer is no. It can't reduce with 7 and it can't reduce with 4. So there's nothing to cross-reduce here. So all I do is I multiply the tops. Don't forget, this first fraction's negative and the second one's positive. Different signs when we multiply yield a negative. When I multiply these two together, I'm just going to do my work out off to the side really quick without a calculator. 3 times 5 will give me 15, carry the 1. 15 plus the 1 I carried should give me 165. Hopefully I did that correctly. And then my denominator gives me 28. And I know that this won't reduce because I've already checked if anything can cross cancel and cross reduce. And if nothing cross cancels or cross reduces, your final answer will also be fully reduced. That's the benefit of cross reducing first. Okay, now let's take a look at division. Now, dividing fractions is very similar to multiplying with one minor change. You have to change it to a multiplication problem. A lot of your teachers may have referred to this as keep, change, flip, where we keep the first fraction the same, we change that division to multiplication, and we flip the second fraction upside down, so that way it yields its reciprocal. And again, I'm going to look for things that can cross reduce or cross cancel before I multiply, just because that's going to then mean that after I'm done multiplying and I get those larger values, the final answer is already reduced. So I'm looking at the 3. It can't reduce with 8, but it can reduce with 9. I can divide both 3 and 9 by 3. That would turn the 3 into a 1 and the 9 into a 3. I can also cross-reduce these 8s. In fact, they cross-reduce completely. They cross-cancel. They both cross-reduce and turn into 1s. Now I can simply multiply to get a numerator of 1 and a denominator of 3. And as I mentioned, since I cross-canceled and cross-reduced first, this final answer is fully simplified. Okay, so a little bit of fraction review. Now let's talk about solving some equations. We're going to start with one that only contains integers. Take a moment to copy this one in your notes. And you might want to draw a line down the equal sign. You might not want to do that. Oops, you might not want to, but you can if you want to. I'm going to try and draw a nice straight line. It's not very straight, but it'll do. All right, so remember all those steps that I had you guys write at the beginning of the lesson. Step 1, distribute. I see parentheses, so I have to follow that step. So I'm going to distribute the 3 into this first group. Okay, you may even want to circle numbers like that. And I'm not just distributing the 7 into the next group, but it's a -7. So be so careful with the signs of your values here. Okay, we're not just going to distribute 7, but we're distributing a negative. The 5 comes down in my next line of work, and then I just start multiplying. 3 times n gives me 3n. 3 times -4 gives me -12. -7 times n gives me -7n. -7 times -7 gives me a +49. This was a very common mistake I was seeing on the honor summer packet, where if students had to distribute a negative and one of those values inside was negative. Also on the homework, some students were making some sign errors. Okay, and then the next step from those 4 steps I had you guys write after distributing, we look for terms that can combine. Well, I've got a 3n and a -7n. That's going to give me -4n. And I also have a -12 plus a 49, which is going to give me a +37. And at this point, I could check to see if there's variables on both sides to do step 3 and collect them all on one side. But I only have a variable on one side, so I can skip step 3 and move on to step 4, which is just to solve, and at this point it's a 2-step. I'm going to subtract 37 from both sides. These are going to cancel out, and on the left I'm going to get a -32, bring down my equals, -4n, and then the last step is to divide both sides by -4. 2 negatives when I divide give me a positive, and 32 divided by 4 gives me 8. There is my final answer. That is such a messy box. Let me try a circle. That's better. Whoops. Okay, let's go to the next slide. Fractions. Here we go. Okay, so there's 2 methods for dealing with fractions. I'm going to show you the old-fashioned way and just deal with the fractions throughout. And then I'm going to show you another way in which you can actually clear the fractions. Now, clearing the fractions, what I will say is this. Sometimes it makes the problem easier. Sometimes it really doesn't. And I would say choose the method that you're more comfortable with. You might be more comfortable not clearing the fractions and just working with the fractions. Use that method. Or you might be more comfortable clearing the fractions and you feel that you're really good at it and that's the method that you prefer. If that's the case, choose that method, okay? But I'll show you both, and I encourage you to try both methods until you make a decision of which way you prefer. We're still going to follow those rules to start off with, though. I see parentheses, so I'm going to need to distribute. So we're going to have to utilize all those fraction operation rules that we reviewed. Now, I'm going to actually do a little work off to the side here when I multiply these values, because when I look at this first product here, 7/3 times 9/2, I'm noticing right off the bat that I'm going to be able to cross-reduce the 3 and the 9. I would hesitate to cross things out right in the problem directly, because when you go to distribute this fraction to the 1, you want to make sure that you're not distributing any different values. You want to make sure you're actually distributing -7/3 to this value and you don't accidentally distribute something where you rewrote the fraction with reduced numbers. So I highly encourage you to do this work off to the side. So I'm going to do -7/3 times 9/2. The 7 and the 2 can't reduce, the 7 and the 3 can't reduce, but I know that the 3 and the 9 can reduce. This is going to turn into a 1 when I divide by 3, and the 9 will turn into a 3. And when I multiply, I get -21 divided by 2. So I'm going to go back over here and write that as my first product, -21 divided by 2. Don't forget, though, that this has a variable of x attached to it. Okay, the more complicated the equation, the easier it is to start dropping terms and variables. And then I'm going to distribute to the second term. Well, 1 times anything is just that anything that you multiplied it with. So -7/3 times 1 just gives me -7/3. And then I just copy the rest of the equation. Okay. So at this point, it's looking like a 2-step. So I'm going to undo the addition subtraction step first, and then undo whatever's touching the variable. Well, the opposite of subtracting 7/3 is to add it. So I'm going to add 7/3 to both sides. I'm left with -21/2 x equals, my signs are different here, so I have to actually subtract, and when I do that, I get a -126 divided by 3. Now, -126 divided by 3, 3 can actually go evenly into a 126. There's actually a trick to determining if a number is divisible by 3. If you add up all the numbers in a value and the sum is divisible by 3, the entire number is. So when I look at 126, I can do 1 plus 2 gives me 3, 3 plus 6 gives me 9, 9 is divisible by 3, so this entire number is divisible by 3. So I'm actually going to reduce that value before I keep going. I still have to work with a fraction though, so I'm going to leave it in fraction form. Even though it's going to work out as an integer, I'm just going to stick it over a 1, okay? And 3 goes into -126 42 times. And then the last step is to get rid of this fraction that's being multiplied with x. Well, the inverse of multiplication is division, but we reviewed that when you divide fractions, you end up multiplying by the reciprocal. So we're going to skip that step and just multiply by the reciprocal right off the bat. So I'm going to multiply both sides by -2/21. These will cancel on the left. And then again, I'm looking for things to cross-reduce and cross-cancel because in my opinion, it's easier to reduce first versus later when you've got bigger numbers. The 2 can't go into 21 or 1, and the 21 can't go into 2, but it actually can go into 42. You might be looking at these numbers and you might have noticed that 21, when you add it to itself, gives you 42. So I can actually divide 21 by itself and get 1, and divide 42 by 21 and get 2. Now that I've cross-reduced everything, I can multiply and my final answer should already be reduced. The two negatives will cancel, leaving me with a positive, and then 2 times 2 gives me 4 up top. Denominator is 1. You can leave it as 4 over 1, or you can simply write it as 4. So that's one way that you can do equations with fractions. So I'm actually going to go to the next page, and it's the same exact equation. So we should be getting an answer of positive 4 if we do this method correctly, but we're not going to do it the same way we did last time. This method, which I call clearing the fractions, first we're going to start it off the same way. Okay, we're going to distribute, and we're going to get, and I'm just going to kind of cheat and look off to my work here. It's already written out, so I know I don't make any mistakes when I do these. When we did that for the last problem, we got 21 halves x minus 7/3 equals negative 133 divided by 3. Now, to clear all of these fractions, what you got to do is you have to look at all the denominators in the equation, and you want to find their LCD. Okay, so I'm looking at 2, and then both of these are 3's. So I'm trying to think, what's the smallest number that 2 and 3 can both make through multiplication? Well, the smallest number would be 6. Then what you do is you take this LCD and you multiply it to every single value. Even if you've got an integer value and it's not a fraction, you still multiply it to every single term in your equation, but only the tops. And then what ends up happening is, because these are technically numerator values, they're going to cross reduce with all those denominators. The 2 is going to reduce completely and turn into a 1, and it'll turn the 6 into a 3. This 3 will reduce completely and turn into a 1, and it'll turn the 6 into a 2. This 3, again, will reduce into a 1, and it'll turn the 6 into a 2. So what ends up happening with all your fractions, you see how they're all over 1? Well, you don't have to write a number over 1. You can just write the number. So we clear all the fractions, and we end up getting nothing but integers. Now, in order to get what that integer is, you take this reduced value that you have left, and you multiply it by whatever number was still in the top. So in this case, I've got negative 21, and I'm just going to multiply it with 3, and that is going to give me negative 63x. I'm going to multiply this negative 7 with this 2. That's going to give me negative 14. And then I'm going to multiply negative 133 with 2, and that's going to give me negative 252. Now, you might be looking at this and thinking, Miss Lorette, those numbers, 63, 252, those are big numbers. That didn't make the problem any easier. And it's like I said, sometimes clearing the fractions makes the problem easier because it's easier to work with integers sometimes, and sometimes it doesn't make it easier. So you have to make the executive decision on what method you're more comfortable with, and then stick with that method. Okay, I usually like to clear the fractions. So at this point, again, it's a 2-step. So I'm just going to add the 14 first, bring down my negative 63x. My signs are different here, so I have to take their difference. And when I do that, and I just realized I made a mistake here, this is not going to give me negative 252 up here. Whoops, I am jumping the gun. Even though I took notes off to the side, I still made a mistake. This was actually, let me do it in blue. This was actually negative 266. This is why I should not film at the end of the day. Okay, now when I subtract these, that's when I get negative 252. That does not look like a negative. Negative 252. There we go. Okay, so just make sure that you go back and make that adjustment. That was my mistake. Okay, and then the last step would be to divide both sides by negative 63. And I've already worked this out, so I know that these two negatives will give me a positive, and that when I divide here, it's going to give me 4. But you can certainly verify with a calculator to make sure that we do indeed get the same answer, regardless of which method you choose. Okay? All right, let's take a look at another example, some more integers this time. And again, you can draw your line down your equal sign. I don't think I will this time. I'm just going to dive right in. I see parentheses, so I have to distribute. I'm distributing 2 into the first group and a -3 into the second. It's not just a positive 3, it's a -3. 2 times 5 will give me 10n. 2 times -3 gives me -6. -3 times -3n gives me -9n. And -3 times -1, the negatives cancel. I get a +3. And then I bring down my equals, -n plus 2n. Okay, so I've got a lot of terms here, so I definitely have terms I can combine. On the left-hand side, I've got 10n minus 9n. That just gives me 1n, or n. I also have a -6 plus 3, which gives me a -3. I bring down my equals -n plus 2n, and I've still got some like terms on the right. -n plus 2n, that's going to give me +1n, or just n. Okay, so I've done step 1, distribute, step 2, combine like terms. Now I do have to do step 3 and get all my variables to one side. It doesn't matter if you move the one that's on the left to the right or the one that's on the right to the left. If all your arithmetic is correct, you should get the same answer no matter what. So I'm going to just try to move the one that's on the right to the left. To do that, you add or subtract the entire term, including the number that sits in front of it. So this is a positive n. The opposite of a positive is a negative, so I'm going to subtract it. When I do that, I'm going to be left with a 0 on the right-hand side because there was no other number on the right. There were no other terms. But what I do to one side, just as always with an equation, I must do to the other. So I'm going to subtract an n to the left, and notice how I stacked it underneath the variable term. This is a variable that I'm moving, so I can only combine it with another variable. But what does n minus n give me? Well, on the right, it gave me 0. So on the left, these are also going to cancel and give me 0. And what I'm actually left with is a -3. So now I'm looking at this, the variable is gone, and I get -3 is equal to 0. Well, is that actually true? Is -3 equal to 0? And of course, the answer is no. They're two different numbers. They are not equal. And as I said, when you get something like this, your final answer should be the phrase, no solution. You have to have that phrase as your final answer. Okay, let's take a look at one more problem, and then I'm going to call this lesson done. And of course, it's going to be another fraction problem. So if you want to pause the video and try it without clearing the fractions and see what you get, feel free. If you want to keep practicing with clearing the fractions, follow along with me. Or again, you could try it on your own first. But I'm going to use the clearing the fractions method, okay? So when I do that, I'm looking at every single denominator in this equation. Well, I see 3 unique denominators. I see a 2, I see a 3, and I see a 6. So I'm trying to think of the smallest number that all 3 of those can create. Okay, what's the LCD that all 3 values can create? Well, that would actually be 6. 3 can create 6, and 2 can create 6. So my LCD in this case is going to be 6. So I'm going to do the exact same thing I did in the last problem and multiply this LCD to every single term in the equation, but only the tops. So I'm going to do times 6 here, times 6 here, times 6 here, times 6 here, and times 6 here. And if I'm doing this correctly, all of these denominators should turn into 1s and reduce those 6s into something else. Well, these 6s will cross-cancel completely and both turn into 1s. This 3 cross-cancels with the 6 and turns the 6 into a 2. When you're doing this, you're just dividing. Same thing here. This 3 turns into a 1 and the 6 turns into a 2. Likewise, again, 3 and 6. This turns into 1. This turns into 2. And then the last denominator, this will turn into a 1, and the 2 reduces the 6 into a 3. Okay. So next step is to multiply whatever numbers I have left in the numerators. I shouldn't need to write these as fractions at this point. They're all over 1. So I'm left with for my first term here, I have a negative. I can't forget about that. And 1 times 7 just gives me 7. Again, I have a negative for the next term. And then 5 times 2 gives me 10. And don't forget that there is a variable attached to that. So there's an a. I'm going to copy my equals and keep going. This is also a negative. 5 times 2 gives me 10 again. And there's an a. I get another negative. 5 times 2 gives me 10 again. There's no variable, so no need to write one. And then a plus. And then 1 times 3 gives me 3. So now when I'm looking at this, personally, I think this equation looks a lot easier to deal with than all of those fractions. So in my opinion, this is one of those equations where clearing the fractions is a little more helpful, because now we're working with all integers. And now I can just keep going. There's no parentheses, so I don't need to do anything here. And as I mentioned before, even when you're working with clearing the fractions, if you see parentheses, you still have to distribute first before you attempt to clear the fractions. I don't know if I made that very clear in the last example. So I'm going to combine my like terms. I only have these two to combine. When I do that, I'm just going to copy everything down first. When I do that, negative 10 plus 3 gives me a negative 7. I have variables on both sides, so at this point, I am at step 3. I'm going to try and collect them all to one side. And again, it doesn't matter which one you try and move. You should get the same answer no matter what. I'm going to try and take the one on the right and move it to the left. It's a negative. That means I have to add. These go away. But then when I add it over here also, these are also opposites, so these go away as well. So I'm left with a negative 7 on the left. I'm left with a negative 7 on the right. All my variables are gone. It ends up being a true statement. Negative 7 does equal itself. So when you get something like this, you can say all real numbers as your final answer. You can also say infinitely many solutions. You can also say that this is an identity. A lot of different ways that you can put this into words. This tends to be a very common way of writing the answer, is saying all real numbers. Whoops. And that is pretty much it. I know I kind of went through a lot here, so feel free to go back and rewatch parts of this video if you need to, and also reach out to your math teacher if you need any further clarification. I'll see you guys next time. Bye.